startup company dealing with the new invention in rapid prototyping. Okay. Micromod, as I said before, is a startup company dealing with the invention in rapid prototyping. And nowadays, it's used a laboratory in Granot, an industrial zone near Hedera. And this is the main room. That's where all the experiments and all the software and hardware has been made. Stop. Hello, my name is Danny Lipsker. I am the inventor of the new rapid prototyping system. The system that we invented works with wires and an adhesive. And basically, what it does, it creates three-dimensional physical models directly from any CAD/CAM software with the help of any kind of wire, of any kind of material, and in any thickness. Later on, we will show you a demonstration of how it works. To start the building of any three-dimensional model, we open the software written in Micromod, and we choose a file. We just open a file. We can open files from two different kinds. The first is the very common DXF, and the second one is STL, well known in the industry. Okay, we choose from a source of files that we created before. And then it appears. Now the file that you see is a very simple one. It's just a square with a circular base. Now, we choose a material that we want to work with. Let's say copper, nylon, PVC, or whatever we want, or steel. We choose a thickness, let's say, for example, 0.28 millimeters, and when we see the slices. Now, what we see actually is the same file, but now with a thickness of 0.28 millimeters. All we have to do now is to say to the robot, just show me how it's going to look like. Then we make a simulation. It tells me that it's going to take 52 slices. It's going to take, as you can see, it shows in a virtual mode each slice, as we can see here, slice number 1, slice number 2, etc., until it comes to the slice 28. We can stop the process whenever we want, yes. And then we said to the robot, all right, let's build it. Robot build. Now, a screen with a few parameters opened up, and we just said, okay. It tells me it's going to take 52 slices, and the time is going to be, with these parameters, 193 minutes. It means 3 hours. And the wire length is going to be 13 meters. Okay. Now what happens? Now the robot zero-sets himself. Now it's time to locate a cassette. Now A cassette holds a wire, adhesive, a needle, and a special device to snap it on place. That's it. Stop. Located the cassette in place. We just press OK on our software, and the robot knows that it is allowed to start the operation, and the operation starts. Okay. UV light activates the adhesive. The wire soaked previously with UV adhesive starts to be glued on a PVC sheet. Actually, what happens is a continuous gluing procedure. It will build up layer after layer until it finishes the entire model. Now the process can be speed up 3 or 4 times. I will show you in the second slide how I speed it up. No, for sure. This is our first prototype, in which we can see only the outer loop of the wires. But now we are working on a second prototype which shows how to do a full model with inner and outer loop with solidified liquid between them. If I want to change parameters, building parameters in the middle of the process, there's no problem. We just go to the options, robot, and then I change parameters. And then, as you can see, now, instead of 190 minutes, the time left is only 69 minutes because I doubled the time. I can simplify it even more. We can finish a model like this, even though it's a simple model, in a matter of 20 minutes or 30 minutes. As you can see, the model is built with a cotton line. Now the thickness of the cotton is 0.28, as we bought it from the store. The cassette holds the wire or the thread as it is. We don't change it, we don't do nothing. We just put the wire or the thread as it is. Now, as you can see, the purple light is a source of UV specially dedicated to cure the adhesive in fractions of a second. And then you receive a very strong mesh immediately. In the same manner as we can do with cotton, we can do with steel, copper, PVC, leather, gold, or any kind of metal or plastic that exists today. as you can see, I will pause the procedure for a while so you can see in the meantime what has been built. You see? Now 7 layers of the model have been built already, and I will continue the procedure. The system was designed to change cassettes of any wire or any adhesive, any appropriate adhesive, just by snap. We use the concept of an ordinary office printer, that when the cassette runs out, you just change it and you continue to work. Now, the model built is a simple one. As you can see, before on screen, it was a circle with a square on top. It's like an academic hat. But we can do any kind of geometry. It's not limited. You can also see that we don't need support because the wires are glued on top of each other. So you receive a physical strength dynamically and directly from the procedure. This is a sample cassette. In this case, the wire is a steel wire. As you can see, it's a very, very thin steel wire. The thickness is 0.1 millimeters. Inside, as you can see, is the same technology. You have wire, you have a reel of wire, and a special adhesive, also activated with UV light or with other technologies. The adhesive must be in the dark. That's why the cassette must be closed. Now, as you can see, this kind of snaps just suit to the device prepared in the robot. You just snap it in and it continues to work. We intend to do a kind of reconnaissance device so the robot will know what kind of wire and what is the amount of wire hold inside and what kind of adhesive is inside, and then when we snap it, it knows it automatically. Okay, this is a sample of the snap. A similar part already works in the robot. As you can see, it's a very simple plastic part. This is also a very simple plastic part. As I told you before, we intend to do similar parts with the technology similar to the printers. After a few months of experiments with our first prototype, we came up to a conclusion that we need few other devices and to improve also the system as it is today. So we took a software named SolidWorks to design a new kind of cassette and head of the machine. And what we did actually is we added a knife and a pump. Now the knife or a scissor is to cut the wire whenever we want to achieve better performance, and also to do non-continuous wire models. Now, actually, the knife can be seen in here. See? We just move it, and then we see scissors, right? As you can see, with the movement, by using one solenoid, we just cut the wire, and we stop when we want, and then we continue from the place that we wanted. The mechanisms are very simple, and this is our motto in our company, to do only simple things. And now it's in our final step of design, and we believe that in 1 month or 2 it is going to be built in a workshop nearby. Also, we made some improvements in the cassettes with a kind of tension device held inside, and also we improved the needle to ease the insertion of the wires. Remember, we are talking about very, very tiny and very small diameter wires with high precision. That's why we have to do a special kind of needle with a material that can hold the wires in a precise position and work for hours. Okay, now I will show you some samples of models made by the same robot in different materials, different sizes, different forms. For example, you have a star, a slanted star, or a shape of a toy car, or just a twisted form. All these samples were made by the same cotton line that we are building now our sample. But as I said before, we also made from steel. There's a steel, copper, also copper, polyester, or silver. Steel. We can do any kind of shape, in any size, in any thickness of wire. It doesn't matter. We use the same software. The only change is in the size of the robot. The same principle, a cassette with the wire, with a photopolymer or a kind of polymer or glue inside, with a needle, and the only change is the size of the robot. Now we use a robot that can build up to 300 millimeters to 200 millimeters to 100 millimeters. But with the same principle, we can do it in a hangar. After half an hour of work, the model has been finished. After the procedure has been finished, I cut the thread and just take the model and let's make a comparison. As you can see, it's the same. Thank you.
אני מקליט אותו.